Welcome to another tutorial for RainWorld. This time we'll be handling a request by one of the commenters on one of my videos. This person wanted to know how to change the jump height and run speed in RainWorld. Now, run speed turned out to be a bit problematic. I managed to get something to work and I hope it makes you happy. If not, too bad. This is as far as I could get. So, let's begin. Open up the NSpy and open up assembly-c#.dll in your RainWorld folder if you haven't done so yet. If you don't know how this works, I've explained in my other videos. I'll link one of them in the description below. Follow that one first if you don't know how to use these tools. If you do, follow along. So, we're gonna go to the player class because we want to do jump speed and run speed of the player. And in the other videos, I've often mentioned that you need to think of words to describe the thing you're looking for. So let's start with jump speed. Well, we'll think of jump. So look for jump in the list or use the magnifying glass. And you'll find it right here. So here on line number 6, we'll see that a number is being used in this jump function. Now, just a number by itself doesn't mean much, but if you look a bit further down below, at line 15 and 16, you'll see that it says body chunks and then a number .vel.y. Now, in math and graphics and some other sectors, VEL usually refers to velocity, so that means speed, and the Y refers to vertical movement. So in graphics, in math, when you have two directions that you can move in, like up and down and left or right, because technically it's 4 directions, but whatever, then often they would make the horizontal direction, so the left and right, they'll note that down as an X movement, and the vertical movement up and down would be marked down as Y movement. And you'll see that this means speed vertically equals 6 times number, and below that 5 times number. And if we scroll down a bit more, we'll see vertical Y 9 times number, 7 times number. So the chances are that this number is being used for vertical speed, for jump height. So right click that, edit IL instructions, change that number. I'm going to use 3 in my example, but you can tweak it to whatever you want. Now this isn't everything, because sometimes the code does things that you don't understand or you just haven't seen yet, which makes the behavior different in the game. So in this case, if we look at line 20, it says if the player is wall climbing, then do all this stuff. But note how it doesn't actually say anything about vertical speed. That's because it's going into this wall jump function. And if we click that, we'll see the exact same line from the previous function. And we'll see more vertical speed equals something times number. So this is the exact same number, but it's on a separate line, so we'll have to change this as well. So right click it, edit IL instructions, and change those numbers to whatever you want. And save all. Technically, you don't need to keep this entire line here, but because I'm assuming you're probably not a programmer, and even if you are, you might not know how these IL instructions work. So I try to make the least amount of changes so that the chances that you break something are smaller as well. So this should fix most of the jumps in the game. Not all jumps might look like they've been altered properly, Like some might be more extreme, some might look like they haven't been changed at all. That's because it's a complex game and they have a lot of calculations where this number is not taken at face value. It's being used and then multiplied times another number, divided by another number. So the 3 times as big number might not always look like 3 times as big, depending on what you're doing. Sometimes it might be more, sometimes it might be less. It really depends on what you're working with. Now you could technically fix that, but that could be so much effort that it's not worth it. I'm not gonna handle it in the tutorial, but if you really want it to be fixed so that everything feels like it's increased exactly the same amount, then feel free to experiment on your own and let me know what you found out and what you've achieved. So, jumping's fixed. Wall jumping's fixed. There's this jump on chunk thing, but I'm not gonna look into that now. And I think this is more about the chunks that you are that you are jumping on rather than your own body. So we can ignore this, I think. So let's go on and move on to movement. Now, you might have already seen it, but there's something called movement update in here. So that might have something to do with our run speed as well. So click on that. Now, if you look at this, it's a pretty big file. It's like 600 something lines. So I'm not gonna explain exactly how you can find out how to change this. I'll just tell you what I discovered and how to make the changes to get it to work, right? So, at line 291, I found out that there's this thing called dynamic run speed, and it's being set to a maximum run speed. So I click that, and we'll see the maximum run speed equals some number, and we'll see acceleration equals some other number. Happens to be 2/3 of the maximum speed. So go ahead, right click it, edit IL instructions, change the number. I'm gonna use 20, and then I'm gonna use 14 for acceleration. Don't use these in your own game. They're too big, so it might be pretty hard to use them properly and to play the game properly. Okay, so save this just in case. And now I've moved back to the movement update where I initially found those lines. And now I'm going to look for some spot where it's going to use that or use some other numbers to set the horizontal speed of my character. And I found out that that turns out to be in here. It starts at line 451 and it goes on for quite a bit, but the most important area is 463 until 500 basically. So in here some stuff is being done. You can ignore that. Look for line 475. You'll see body chunk velocity x equals body chunk velocity x minus number 12. Now, what we want to do is right click that, edit IL instructions, and then you'll see the highlighted part. This equals exactly that one line. And now what I want you to do is click on line 2735, the one that says V_29, and that's right above sub. Click that. Press C twice. Change the knob that appeared, the first one, to LDC R4. Put down a number. I'm going to use 3. Change the second knob to MUL or multiply and press OK. if you've done it properly, you should be seeing this. Originally, the times 3f was not there. We just added it through the IL instructions. Some people, if you've talked to other modders or seen other tutorials, they might tell you to use right-click edit method, or they might say that they want to do that. But the reason I always use IL instructions is because sometimes you get errors when trying to use it with edit method, and editing it through IL instructions is the safest way if you know how to use them. So move down to line 488 and you'll see the same thing. Body chunk velocity x equals something plus number 13. So right click that one, edit IL instructions, and we'll see v underscore 30, and below that the line add. So in this case we'll do the exact same thing. Click the line 2784 that holds the v underscore 30. Press C twice. Change the first knob to LDC R4. Give it a value. I chose 3. Choose the second knob. Turn it into a mul for multiply. And press OK. If you did it right, again, times 3f should have appeared, or whatever number you have used instead of 3. One thing to note is that for the computer, stuff like 1 plus 1 is not written down as 1 plus 1, but as 1 1 plus. So you can see that here. We did multiply by 3, but in the IL instructions you see the 3 first and then the multiply. And that v underscore 30, that is that num 13 in the original code. So you're probably not gonna need that knowledge, but I think it's a fun little detail that our computer doesn't process it this way. It always first puts the numbers and then the operation. So, having done this, there's just one more that I found out that I had to tweak, and that's line 496, or the line containing this clamp operation. And what we want to do here is change dynamic run speed to be either a number or just make it refer to our maximum run speed, for example. Now, you might be thinking, didn't you show us that line that said dynamic run speed equals maximum run speed? And I did. So then why change it to maximum run speed here if it already has that value? Well, if we go to the other code that I didn't show you, there will be a line that changes this value. And I haven't looked into it too deeply, but it changes it enough to the point where it's less than maximum run speed. So what this is basically doing is causing us to run not as fast as our maximum speed would allow. So right click it, edit IL instructions. Now you'll see dynamic run speed. Click it and click on field. Now look for maximum run speed. Click it and click OK. This isn't everything. Below it you'll see the v underscore 28, and below that you'll see ldlm.r4. Click those lines one by one and press delete. And for this one, the first one, you'll only see this neg be underneath it. If you see that, you've done it correctly. Press OK, and you should be seeing this. The first dynamic run speed has turned into minus this max run speed. Now we're going to do the same for the second one. Right click, edit IL instructions. look for that second one. It's right here. Line 2825 after having edited the first one. And click it. Click field. Click max run speed. Press OK. And remove those extra 2 lines that we don't need. The v_28 and the ldlm.r4. If you've done it correctly, it should say max run speed followed by clamp, float, float, float. Press OK. And you should see max run speed only in that line. Like this. Now, this is as far as I've checked the run speed changes, and it works. So I'd say have fun with this. Try to tweak the numbers where I put 3s or 20s or whatever I used to get a better speed for actual gameplay. But I hope you'll have fun with this. And I'll show you the results just to show you that it's working. But that's it as far as the actual code changes go. So, starting the game. Waiting for Slugcat here to wake up. And you can already kind of see it. I have to try and be... There we go. So if you haven't played the game, you might not realize, but this is definitely not how fast he usually runs. And that's not how fast he usually jumps. Now, I've told you before that sometimes the code does weird things with your numbers, so it doesn't look like you've changed it to jump 3 times as high. So for example, my regular jump is maybe 3 times as high, I'm not sure, but it might be. But my somersault jump looks like it's way higher compared to the increase that you get in the original game. In the original game, I think you jump maybe like 1/10 of a Slugcat higher, but here, if I can do it again, you jump like 10 times higher or whatever. So that's because of the crazy numbers magic that's going on in the code. If you want to fix this and make sure the somersault jump doesn't go that much higher than your regular jump, experiment with the code. Try to find out where that piece is that's making it jump way higher and then tweak it. That's all I can tell you. I'm not going to show you it in this video, maybe in a future one. But you're gonna have to experiment if you don't like that weird difference between jumping heights. Same thing with the poles. Let me show you. I just jumped from a pole and that's what happened. So you can see the movement feels a bit weird. Like I go really fast in one direction, I change to the other side, and it goes really slowly. This stuff, you're really just gonna have to experiment with the code and try to figure out how everything works. But for now, I hope this will satisfy you. I hope you've managed to follow along and managed to get the run speed and the jump height working. And I hope you'll have fun with these changes and enjoy the game and the tutorial. See you next time. That was it. Goodbye.